Hello, my name is Vishal. Today we are going to discuss about triangle chapter, class 7, geometry essentials. So, what is a triangle? All of you see this structure is a triangle. What is a triangle? A triangle is a closed plane figure formed by three lines. First line, second line, third lines connecting to three non-collinear points. First point, second point, and third point. These three points are non-collinear. It means the simplest polygon and one of the most important shape in mathematics. Key points: three sides. Triangle has three sides. First side, second, and third side. Also, it has three vertices. First vertex is A, second vertex is B, and third vertex is C. Also, three interior angles. First angle, second angle, third angle. And this is called as triangle. Note triangle ABC representing triangle with vertices labeled as A, B, C. This triangle is a triangle ABC. Next, parts of triangle. Parts of triangle. There are three main parts of triangle. First one is sides. First one is side. The three line segment that form boundary of the triangle. First, second, third. These are the three lines of three sides of triangle. First one is this side is AB, this side is BC, and third one is CH. So triangle contains three sides, namely AB, BC, and CH. A to B first side, B to C second side, and C to A third side. Then vertices. Triangle having three vertices. First one is A, second one is B, and third one is C. These are the three vertices of triangle. Then angles. Triangle having three angles. First one is first angle, angle A. Second one, angle B. And third one, angle C. With different measurements. Next, types of triangle. Next one is types of triangle. So first triangle type is equilateral triangle. First type is equilateral triangle. A triangle having all three sides are equal in measurements. First side, second side, third side. A, B, C. All sides of triangle are equal. For example, AB is equal to BC and BC is also equal to CA. Also, their interior angles. Angle A is equal to angle B equals to angle C. That means all three sides of equal length. Each interior angle measure 6 degree, and this triangle is called as equilateral triangle. Second one is isosceles triangle. Second one is isosceles triangle. The triangle in which two sides are equal. For example, AB, side AB is equal to side AC, and angle B is equal to angle C. Two sides are equal in length where AC, the angle of the equal side is also equal. So angle opposite to each side is B angle, and angle opposite to AB side is C angle. It is also equal. This triangle is called as isosceles triangle. Third one is scalene triangle. Third one is scalene triangle. So all three sides having different lengths. Similarly, all three interior angles are different. For example, this AB side, BC side, and CA side. This measurement 4 meter in length, 5 meter in length, and 6 meter in length. All three measurements are different, and all the angles are also different. For example, this angle is 70 degree, this angle is 30 degree, and this angle is 80 degree. So all the three sides and all angles are different in measurement. This angle is called as scalar triangle. Next one, types of triangle by angle. Types of triangle by angle. First one is acute triangle. First one is acute triangle. The three interior angles are less than 90 degree. Each angle is acute, creating sharp looking triangles. For example, triangle has three angles, and each angle having measurement less than 90 degree. For example, this triangle is 60. This angle is also 60. This angle is also 60. So this triangle is called as acute triangle. Then right angle triangle contains one angle that measures exactly 90 degree. For example, in triangle ABC, angle B measures 90 degree, and this triangle is called as right angle triangle. Next one is obtuse triangle. Has one of the interior angle is greater than 90 degree, and this triangle is called as obtuse triangle. For example, in triangle ABC, in triangle ABC, measurement of angle B is 120 degree and which is greater than 90 degree. So this triangle is called as obtuse triangle. This triangle is called as obtuse triangle. Next, key properties of triangle. Next one is key properties of triangle. First property, angle sum property. Angle sum property. The sum of all the three interior angles is equal to 180 degree. So angle A plus angle B plus angle C is equal to 180 degree. This is first property. Then triangle inevitability theorem. The sum of the length of any two sides of triangle must be greater than third side. So if A plus B, if we measure A plus B is greater than C. If we measure B plus C, which is greater than A. If we measure A plus C, which is also greater than third side B. Next, exterior angle property. Exterior angle property. Add exterior angle of the triangle equals the sum of the two not adjacent interior angles. For example, exterior angle A is angle B. Next, special lines in triangle. Special lines in triangle. First one is median. First of all, we can draw a triangle in which side A, B, C. On this side, we can draw a single line perpendicular to BC line. So AM is perpendicular to BC. Median. A line segment drop on vertex. A line segment drop on vertex A to the midpoint of the opposite side. To the midpoint of the opposite side. All the three medians intersect at the single point. And this point is called as center. This point is called as center. This point is called as center, which is the triangle center of the gravity. Next one is altitude. Altitude means height of triangle. Altitude means height of triangle. A perpendicular line drawn from the vertex to the opposite side. A perpendicular line drawn from the vertex to the opposite side BC. All three altitudes meet to arc center, which can be like inside or outside the triangle. This is the altitude of circle. Then angle bisector. Angle bisector. A line that divides an angle into two equal parts, and these three angles bisect meet interior part. This is called an inscribed circle. For example, this is also a triangle ABC. ABC. If we draw bisector AD, then bisector BE, then bisector CF. So this point C2F, B2E, and A2D is called as angle bisector. Is called as angle bisector. Next, right angle triangle. Next one is right angle triangle. In right angle triangle, one of the angle is measured at 90 degree. Understanding the right angle triangle, first we can draw a triangle with one of the angle is 90 degree. With one of the angle is 90 degree. The hypotenuse is the side opposite to right angle. This side is called as hypotenuse side. This side is called as hypotenuse side, which is just opposite to right angle, and it is always the longest side of the right angle. It is always longest of the right angle. Pythagoras theorem. We can use Pythagoras theorem to calculate one of the length in right angle triangle. So hypotenuse square equals to, this line is base and this is height of right angle. This line is called as height of right angle. So we can use C square, then A square and B square. So hypotenuse square is equal to C square, then base square is equal to A square, and height square is equal to B square. So Pythagoras theorem shows that C square is equal to A square plus B square. This Pythagorean theorem allows you to calculate length of any side if we know the other two sides. If we know two sides, for example, base side and hypotenuse side, we can calculate height. If we know height side and base side, we can calculate hypotenuse side. So this theorem can be used for calculating one of the sides that we cannot know. Next, real life examples and applications of triangle. First, we can use different shape of triangle in road safety. We can see triangle shape on in the side of road. Triangular warning sign are universities recognize their shape, drawing immediately attention to important information. Then architectural and engineering, roof trusses, then bridges and towers use triangular structure because triangle distribute weight evenly and provide exceptional stability. Third one we can use in designs and art. From packaging and graphic designing, triangles create visual interest and guide the viewers eye through composition. Next one, summary and why triangles matter. Summary and why triangles matter. First one is structural strength. Triangles are the strongest geometric shape in engineering. Unlike square or rectangle, they cannot be deformed or break without any change in the length of their side, making them ideal construction. Second thing, fundamental of geometry. Understanding triangles builds the foundation of advanced topics like trigonometric, circle theorems, the coordinate geometry, and three-dimensional structure of shapes. Last one is practical application from navigation and surveying the computer graphics and physics. Triangles are essential tools in the science, technology, and everyday problem solving.